Okay, in this video we want to begin to look at the homework exercises. And first we want to solve literal equations for y. And that just simply means to isolate the y in the literal equation. Well, for the first one, we're almost there already. We have y minus 3x is equal to 13. We add 3x to both sides, and we simply end up with y is equal to 3x plus 13. And so that would be our answer for the first literal equation, solving for y. Just a note, 3x plus 13 does not equal 16. It does not equal 16x. You can't add the 13 and the 3x because these are not like terms. So the most we can do is say it's 3x plus 13 or 13 plus 3x. In the second equation, a little bit more complicated, but also not too bad. We have 2y minus 18x is equal to negative 26. So since our goal is to isolate the y, so we want to make sure that we don't touch that, and we're going to get rid of everything else first. So we're going to add 18x onto both sides, and just like with the previous problem, we can't add 18x and negative 26. The most we can say is either 18x minus 26 or negative 26 plus 18x. And that leaves us with 2y on this side. If we were to divide both sides by 2, we would end up with y is equal to 18x minus 26 all divided by 2. But with this one you can also divide everything by 2 easily, and so we're going to get 9x, or we could get 9x minus 13. So either of those would be sufficient for right now. Later on we're going to see that the 9x minus 13 is actually much more helpful in telling us something about that equation. Okay, we'll move on to number 7. Alright, for number 7, 9x minus y is equal to 45. Now I might do two things here. One is, I know I want to isolate the y, so I can subtract 9x on both sides, and that leaves me with a negative y. You have to make sure you get that negative y there, and then minus 9x plus 45 if we want to put the x term first. Otherwise it would be 45 minus 9x. However, we can't leave it like that, so we need to multiply everything by negative 1. Multiplying everything by negative 1 just means to change all the signs. So we would end up with y is equal to 9x minus 45. And so that would be our final answer for number 7. Finally, for number 8, we have 4x minus y equals 7 plus 4y. The goal again is to isolate the y, and so we want to get rid of everything else that's around it. So the first thing that I'm going to do is subtract 7 on both sides, and we can definitely do something with that. We have 4x, and then the minus 5 and the minus 7 can be combined to a minus 12, leaving us with 4y. At this point we can divide everything by 4. I'll write it this way just to show that everything is being divided by 4, and then I'll rewrite with the y term on the left. So those 4's cancel. The 12 divided by 4 gives us 3. These 4's cancel, and so we would end up with y is equal to x minus 3. And that should be our final form for that particular equation. Okay, we're going to go on to the next set of equations where we're going to solve for x instead of solving for y. Okay, so with number 13, 15, 17, and 19, we're solving for x instead of for y or for what we're solving for x instead of for y or whatever other variables there are there. Sorry about that. All right, well, sometimes we can see that there are things that we can do. We don't really have that big of a challenge ahead of us. So we're starting with number 13. We have y is equal to 4x plus 8x, but here we do have like terms, so we simply can rewrite this as y is equal to 12x. And then if we wanted to solve for x, all we'd have to do is divide both sides by 12, so that x is equal to y divided by 12. And so that would be our answer to the first equation, solving it for x. Now in the lesson, we did talk about some cases, such as number 15, where we can't combine. For example, we have a is equal to 2x plus 6xz. And we can't combine those because of the z term that's in the 6xz. However, we can factor out an x, and we would get 2 plus 6z. So x times the quantity 2 plus 6z is equal to a. So we can see that if we multiplied back, x times 2 would give us 2x. X times 6z would give us 6xz. Alright, and now our only job left is to isolate the x. So we're going to divide by 2 plus 6z, divide by 2 plus 6z, and so we get 8 is equal to, 8. X is equal to a divided by 2 plus 6z. And so that would be our answer for the second question. All right, in number 17, we are going to be able to do a similar type of thing, only we have a 6 in addition to that. So what I might do first is just isolate all of the x terms by getting rid of that 6, subtracting 6 on both sides. We'd get y minus 6 is equal to 4x plus rx. And then we can use the factoring technique to bring out an x. We'd have 4 plus r is equal to y minus 6. Multiplying back, x times 4 is 4x. X times r is rx. So that's fine. The last step in isolating the x would simply be to divide both sides by 4 plus r, and we get x is equal to y minus 6 over 4 plus r. Right? So we just have one more like this. And again, this is a skill that's going to be used a lot in algebra when you're solving for a particular variable, solving a literal equation for a particular variable, isolating that variable on one side of the equal sign. Okay, we'll come to the last example here. Again, our goal is to solve for x. So we start with s times x plus t times x equals r. Now, we can't combine those. They're not like terms because of the difference in the s and the t. However, we can factor out an x, and we would get x times the quantity s plus t is equal to r. At that point, we would divide both sides by s plus t, and we end up with x. Obviously, these cancel here as they're canceling in each of the other cases, each of the other problems, to isolate the x. And now we get x is equal to r over s plus t. And so we have all of these equations solved, and we'll go on to look at some of the word problems in the next video.